Algebra 1, Unit 6, which is on solving inequalities. So here we're going to go and look at the day 1 notes, okay, which is really our intro into solving inequalities, determining what an inequality is, how we solve for an inequality, how we determine what is and isn't a solution to an inequality, and how we graph that on a number line. So just going to go through some of the notes here and kind of glance around, and hopefully this will be helpful to you as we then go through the lesson. So first off here, it asks you which one of these doesn't belong. You really could defend any of these answers, right? I would tend to say B here, and I would say just because this one doesn't have an inequality, right? This is an equation. Now technically here, any of these answers could be correct, okay? All right, so let's get into what we're looking at. So first off, when we're going to graph these, we're going to graph them on a number line. Now normally a number line is going to orient with 0 in the center of your number line, and your negative numbers are going to progress more negative numbers as we go further left on the number line, and more positive numbers as we go further right on the number line. So here we see our points written in 0, and we want to move them to represent each of these points. So the first point says x is -2, so we're going to drag this over to where we get it right on top of the -2 there. Then we have it at 2.7. So again, we're not being totally exact here, just a general idea. So that should be between 2 and 3, but a little closer to 3, so somewhere in there. Right, then we have x equals 1, so we just move that to a +1, try and get as close to it as you can. And then -3.2, so again, that's go down to -3. -3.2 is a little bit past -3, so somewhere in that region. So that would kind of represent where those points are. As we start graphing the inequalities, we're still going to need to put the original circle, whether it's open or closed, over the correct value, so it's important you know where they are on the number line. Okay, so from here, we need to make sure we understand what an inequality actually means. So here it says to move the 4 points to represent 4 different numbers that are more than 5. Okay, well, let's move it to where that one's at 5.57, 7.16, 6.16, 8.38. So are all those more than 5? Yeah, they're all more than 5, right? And notice it said 4 different. So I didn't just click on the same place each time. They all represent a different number that is more than 5. In other words, in a math term, greater than 5. Okay, and we really could keep on going here, right? It could go anything above 5, right? So with that in mind, let's make sure we understand what the different symbols are, which is really a review from pre-algebra, but it's important that we understand the concepts, okay? So we're going to match each symbol to its name, okay? So greater than is when you just have the greater than sign here, which is the where you're going to have the inequality kind of looking like the larger side is pointing to the left. Less than is going to be where the open side is pointing to the right. And then less than or equal to, the open side is pointing to the right with the line under it. Greater than or equal to, the open side pointing to the left with the line under it. And that line really just means under it, means it could be that number. So instead of like it's greater than 5, it would be it's greater than or equal to 5. And what that does is it makes the number itself a solution. Okay, so now let's go through and make sure that we understand kind of what these different things mean, okay? So if we were going to write this sentence in words, right, what would this read? It's 3 times the value of x minus 2 is less than 5, right? Here this is going to be -4 is less than or equal to y, which is less than or equal to 6, right? So just remembering what those words are going to mean, how we transform those, going back to like our units from the fall. Okay, all right, so what does it mean to be a solution? So a solution is a value that makes the equation true. So if you have something and you plug it in, that it would make that situation true. Okay, so speaking of making situations true, let's look at this. So this says which statement is true. So here it has -3 times -5 is greater than 15. Well, -3 times -5, a negative times a negative is a positive, and 3 times 5 is 15. So this would read 15 is greater than 15. Well, since there's no or equal to sign under here, 15 is not greater than 15, right? It's equal to. And the last one is the same thing, but with a less than sign. So this would read 15 is less than 15, which is also not true. Look at this middle option here, negative 3 times negative 5. This gives us 15 equals 15. Well, that is true, right? 15 equals 15, okay? All right, so then moving from there, what statement's true here? 3 is less than 5, 3 is equal to 5, 3 is greater than 5. 3 is less than 5. Now when I read those aloud, that should be pretty simple. We've got to know what these inequality signs mean. If you know what the signs mean, then those are pretty basic and you would have known that a long time ago. But we do have to know what the symbols mean so that we can answer them easily. So here, which statements are true? 3 is equal to 5? No. 3 is less than 5? Yes. 3 is greater than 5? No. 3 is less than or equal to 5? Yes. 3 is greater than or equal to 5? No. So again, we clicked both of these because this was just 3 is less than 5. That's true. 3 is less than or equal to 5. And in this case, the or equal didn't really matter because the values weren't equal. All right, which statements are true here? So again, negative 3 times negative 5 is 15. So 15 is greater than 15? No. Again, multiply here, you get 15. 15 is greater than or equal to 15. Now that's true because it has the or equal sign. Okay, here it's 15 is less than or equal to 15. That also is true because it has the or equal to sign. This one, of course, is true because they are equal. And this one would not be true because 15 is not less than 15. Okay, so again, as we go through these statements here, negative 3 is less than negative 5. Negative 3 is not less than negative 5. It's not equal to. Negative 3 is greater than negative 5. And again, sometimes that can be confusing with the negative numbers in terms of greater than or less than, but just understand that the bigger the negative number is, the smaller it is. The further left it would be on the number line. Okay? Again, really big emphasis on knowing what the symbols mean so that it then helps us to understand what these are going to be when we read them aloud. Okay, one more slide here with the which one is true. 1 minus 2 is less than 5 minus 10. So negative 1 minus 2 is negative 3. 5 minus 10 is negative 5. Negative 3 is less than negative 5. Again, that's not true. Negative 3 is greater than negative 5 because it's less negative. Negative 1 minus 2 is negative 3 is equal to 5 minus 10. Again, that's not true. Negative 1 minus 2 is greater than 5 minus 10. That is true. Negative 3 is greater than negative 5. Okay? So here it says Portia says 7 is a solution to x is greater than 9. Marcelo says 7 is a solution to x is less than 9. So who's correct? Well, again, put the 7 where you see the x. Is 7 greater than 9? No. Is 7 less than 9? Yes. So then that would mean that Marcelo would be correct here. Okay? Because 7 is less than 9. Right? Alright, so now let's understand how these get drawn on a graph. So here it says to draw on the graph where x is less than 4. So what you're going to do is you're going to put an open circle above the 4 because there's no or equal to sign. And where are all the numbers? If this is a less than, where are the numbers that are less than 4? Well, they're to the left. So we're going to draw a line to the left with an arrow. And that would indicate that that arrow goes left forever. In other words, going back to the last unit, it technically goes to negative infinity. Okay, so it goes left forever. Right? So here, graph where this is on the graph, right? So let's drag this up here. Now, we shouldn't click, if we click on this side, right, this is all showing us that arrow, and that arrow is going to continue going left forever, right? All right, so now we need to graph x is less than negative 2, right? So now we're going to move this to negative 2. Now, since it's a less than, notice where's the shading? It's to the left, right? It's going down. Here, x is greater than negative 3, so the shading now is going to the right. We need to move our circle to where it's at negative 3, okay? All right, is 3 a solution to 2x minus 1 equals 4? Why or why not? Well, let's think about it. If I plug a 3 in here, right, let's follow order of operations. 2 times 3 is going to give us 6. 6 minus 1 is 5. Does 5 equal 4? No. Okay, so why not? When I substituted 3 in for the variable, the equation did not balance, right? The two sides were not equal to each other, so the equation was not true, right? So that would make that a not true statement, right? So we always got to be checking for, does this actually work? Does this make our statement true, right? So let's think about what would make our statements true. So here it says to write two solutions for the inequality. X plus 3 is less than 5. Okay. So I need two numbers here where something plus 3 is still less than 5. Well, the first thing that comes to my mind is 0. Right? 0 plus 3 is 3. 3 is less than 5. Well, couldn't I also just do 1? 1 plus 3 is 4. 4 is less than 5. So those are both solutions. And I also could do what? Any negative number, okay? I could have a lot of different bits here that basically anything that's less than 2. Because if I put a 2 in here, it'd be 2 plus 3 is 5. 5 is less than 5. 5 is not less than 5. So you can have any number here that is below or less than 2. Right? So write two non-solutions for the inequality. In other words, two that don't work. Well, how about 4, right? 4 plus 3 is 7. 7 is not less than 5. And really, isn't it just anything greater than 2? Okay? And again, technically here you could put 2 because that would make it 5 is less than 5, which is not a true statement. Okay? All right. So as we go through here, look at what we're doing. X plus 3 is less than 5. Drag your dots to two possible solutions to inequality. So what did we do before? Well, we said 2, put a point, put a point. Both of those would work, right? So now let's solve the inequality without guessing. So instead of just randomly plugging things in here, what do we actually do? Well, we're just going to solve it the same way we would if it was an equal sign, okay? So here we have x plus 3 is less than 5. We're going to subtract 3 from both sides. When we do that, we get x is less than 2. Okay, so here's what we get. X is less than 2. So now I'm going to put a circle above the 2 and an arrow going to the right because we need less than 2. Okay? So now you can graph all the possible solutions like this. So why is this dot open, right? Why do we have an open circle over the 2? It is because the 2 is not a solution, right? If we were to plug a 2 into this, 2 plus 3 is 5, 5 is less than 5. That's not true. So the 2 is not a solution. So that is why this is an open circle. If it was a solution, we'd have a closed circle, which is a closed circle. So a closed dot would be used for this symbol. So graph the solution. So here it's the same thing. X plus 3 is less than or equal to 5. So you're still going to make the same step here to solve, which is going to be to subtract 3 from both sides. And you're going to get x is less than or equal to 2. Now, though, I'm going to put a closed circle above basically where a 2 would be and draw an arrow to the left. And the reason why is now it says or equal to 2. So 2 does make this a true solution. So now it is a solution, whereas before it was not. So how would I graph x is greater than or equal to 2? I'd put a closed circle above 2. Since it's a greater than, I would draw an arrow to the right. Okay? Because every single number greater than 2 is a solution here. Now it asks us to graph here. As you continue to go through these, keep in mind closed circle, open circle, and what direction does the arrow go. So now we just have to think about it when we have more than one step to solve. And it's really just going to be the same thing as what we did before when we're solving through with equations. So here you see 7x minus 4 is less than 3. So we're just going to add 4 to both sides. And really we're going to go through the same steps as if this was an equal sign. The fact that it's an inequality isn't really going to change anything for us on this problem. So we get 7x is less than 7. That 7 is multiplying by the x. So divide both sides by 7. And we're going to get x is less than 1. So let's type that in our answer choice box. And now let's graph it. Well, we just reviewed, since it doesn't have a line under it, it's going to be an open circle. And it's going to be a less than. So we draw the arrow to the left. Okay? So what about here? Let's just show another one, right? 2x minus 4 less than 3. So we add 4 to both sides, again, just as if it was an equation. When we do that, we're going to get 2x is less than 7. I'm going to divide by 2, and I'm going to get, and here in general, I would change these to decimals. So I'm going to get x is less than 3.5. So I'll type that up here in my answer choice box. The reason I'm going to change it to a decimal is, I think if you see 3.5, you pretty quickly go, oh yeah, that's right in between 3 and 4. A lot easier than if you see 7 halves. So I think it's easier to plot on the number line. So now the only things we have to think of, since we know our solution, is it an open or a closed circle, and where does the arrow go? So again, how does this read? X is less than 3.5. So it should be an open circle because there is no or equal sign under it, and it's an x is less than. So less than, arrow to the left. Okay. All right, so you should definitely try some more of those here with these practice questions. So let's go over the last thing. So there is one special rule that we have to make sure that we understand, which will be our last couple that we'll do here together, okay? All right, so what happens here? When you multiply or divide by a negative, you must reverse the sign of the inequality. So think about just like any time. If you were to multiply 3 by negative 2, then instead of becoming a positive 6, it becomes a negative 6, right? It switches the sign. Well, now it doesn't just switch the sign of the number, it switches the sign of the inequality. So greater than or equal to would turn into less than or equal to, less than turns into greater than. So let's look at two quick examples here. So here we see 2 minus x, and keep in mind this is implied to be like a negative 1x is less than 5. Well, now we're going to subtract 2 from both sides. When we do that, we get negative 1x is less than 3. Now we're going to divide by negative 1. Now, when we divide by that negative 1, we just divide it by negative. So now the sign of the inequality, which was a less than, is going to flip to a greater than. And then 3 divided by negative 1 is negative 3. So our solution box, we should type x is greater than negative 3. Graphing this on the number line, we're going to put an open circle above negative 3. And then this is x is greater than. So we're going to draw that arrow to the right. Okay? Let's look at that one more time, but with some more steps. So here we see x over negative 4 plus 5 is greater than 8. So I need to do my normal steps I would do to solve the problem, okay? So let's subtract 5 from both sides. When we do that, we get x over negative 4 greater than 3. And let's go times negative 4. So times negative 4 times negative 4 to both sides. Now when we do that, we multiply by a negative, so the sign of the inequality has to flip. And now we're going to get negative 12. So x is less than negative 12. X is less than negative 12. So we need to go to negative 12 on the number line, which we can't really see here. So I'm just going to kind of put it over here, and then x is less than, and we're going to take that arrow to the left, okay? All right, so again, that's kind of what we see there. All right, I hope this helps. Make sure that you finish all the rest of these practice questions over the course of not just the asynchronous time, but during your work period for next class, okay? And during that asynchronous day time. As you go through with the statements, make sure you think back to Unit 1 and what we did here with turning the words at least and at most, okay, for whether you're writing greater than or less than signs.